Very good. All right. Well, got a few folks, um, and we do have a few things to cover today. So I'd like to get started. Rao, are you ready to give the tech update?
Yes, I am. Okay, I think we have a couple of demos today, and I think everybody should be seeing my screen right now. So the mainnet, last week I said that we were running the observers with the 0.12.3 version, and that's been going fine. So we will soon be updating the validators on the mainnet to 0.12.3, and that's the one that has what I'm calling a alleviation fix for the tuple space mismatch, which is just if there's a tuple space mismatch, we run the replay a couple more times and see if that error goes away. That seems to be working fine so far in all the environments where we tested. But again, this is not a surefire fix, permanent fix, and that's something that we'll have to get more debugging information to resolve that issue. So that's kind of where we are with the networks. There has not been a whole lot more change on the rest of the networks. And I think Raphael had started working with the block merge testnet and giving it a thorough check. And I encourage other community members, anybody with a DApp, to please test the block merge testnet, so we have we get as much feedback as possible before we get to hard fork 2. So the team is feverishly working on the leaderless block merge and the towards hard fork 2. They had because what we basically ran into with leaderless block merge is that as NutZipper was working through different parts of that, he saw opportunities or need for refactoring in different parts of the code, both from the standpoint of fixing some things as well as some design changes. So the team has been grappling with that, and they now are at a point where they have broken down the scope of the changes into multiple steps to separate the ones that are really needed for leaderless block merge versus other refactorings that perhaps can wait for the next release. So that work is mostly done at this point in time. And so to get through this planning, they had to really go through review of the code, review of the changes and the proposed changes, as well as creating like, what is it that we really want to do based on the review of the code and the design changes that were thought through, and then create a pathway from where the current code base is to the desired end state. So that's why that analysis was a little bit of quite a bit of detailed work, and that's now close to completion, if not completed. So the team will be now working on prioritizing and distributing these tasks among the team members over the rest of the week. And also they're reviewing tests as to how much of impact or changes are needed to the tests. So all of that is part of that review or distribution. So that's where we are. So the focus here is to stabilize the code, the LLVM code, the leaderless block merge code, rewrite the tests and make sure everything is working as expected. So that's what the team is mostly focused on. Dennis is optimizing his radix tree implementation of history for storage to minimize the storage that is needed. He's making good progress on that. And we expect that by the time hard fork 2 rolls around, his changes will be captured in the code base, meaning it'll be integrated with the rest of the changes that the team is working on. At this time, the leaderless block merges, the testnet is still unstable, but the team is aware of the problems that need to be fixed, and they're going about fixing those. And I think by the end of next week, we should have more stability in the network. That's the expectation at this point in time. Stanislav has started working with the code base. He's coming up to speed, and he submitted his first PR to implement get block via hash lookups from the block DAG representation. So this improves the performance of get block. I linked to his pull request and the issue here. Basically, we put out, whenever we know there are things that need to be done, we put out some issues in the code base, and any interested developers can come in, pick from, and we have labeling on those issues to say what is a good first task for somebody new to the code base to pick up. So Stanislav came through that process. He picked one of these items that he thought he could handle, and he has gone successfully down that path now. I think what he's going to do next on this PR is to do some performance measurements and add that data to the PR. And then he's kind of learning the SRE process that we go through so that, to figure out how to run his local node and how to integrate his changes with the rest of the code base and things like that. So I'm very happy to see his engagement with the code base, and hopefully he'll be doing more and more of this in future. So that's where we are. So that I think is my main update by and large. I don't think I've forgotten anything else. Are there any questions or comments on any of this before I hand it over to the next person? Over to you, Greg.
Yeah, so let's see. Is Raphael here? Is he going to give a demo?
Yeah,
Yep.
I think that's the plan.
Okay, awesome. Raphael, over to you.
Okay, let's go. So yeah, today's demo is more focused on dappy. The goal is just to give an update and to refresh the memories and to explain what is this project about. So yeah, I'm Raphael, the lead dev of the dappy project, and so I'll go through this presentation. So what is dappy? Dappy is a web browser and a name system powered by the blockchain, RChain, of course, and yeah, it aims to bring stratospheric levels of trust and accuracy, also to remove 90% of attack surfaces for the attacks that are related to DNS and certificate authorities, and also to unlock new trust models. And I'm going just to focus on those two elements. Greater levels of trust and accuracy. So in 2021, there are hundreds of millions of websites. Those websites are company websites, foundation websites, government websites, and they all use the DNS. The DNS is a name system managed by ICANN, and it maintains a relation between some human readable names and some IP addresses, as well as some TXT records sometimes. DNS is a system where the resolution is centralized. It just means that you will ask a corporation when you need to resolve a domain name to an IP address. So if you are on a .com website, the company that every computer visiting a .com website will target is VeriSign in the US. And of course, there also are national extensions like FR or US. But yeah, the point is that it's trustful. You put your trust in the registry that is targeted by the DNS lookup request. dappy is a system that is based on co-resolution and not single resolution, so it is trustless. and it does mainly the same job, except that we will see that the name system, of course, is on the blockchain and not on a private database like the DNS ones. So this schema could help you understand the bottleneck that I'm talking about. So this is well known in the DeFi or in the blockchain galaxy, the problem of DNS centralization, that you always have to go through DNS to distribute your DApp. So yeah, if you have a .com, you rely on VeriSign, etc., etc. So this is a corporation that is just like every corporation in the world, subjected to legal censorship, illegal hacking, or some kind of downtimes. So the main there are two dappy IDs. The first one is just to have the name system on the blockchain. So it's very simple. You have your IP address, your SSL certificate, and your name, and you put everything on the blockchain. So this way, the private database issue is removed. It's all public ledgers. And the second dappy ID is a multi-request. So the main point is to not rely on a single endpoint when you want to resolve a name. So we don't want to do like the DNS mechanism. We want to do it trustless. So we have to ask many endpoints for any kind of question. In this case, it's resolve the cool app name to an IP address. So what does this system change? It changes everything because this system has tolerance for downtime and for hacking. Those rectangles are independent corporations. It's very unlikely that they could all get hacked in the same time. So by doing multi-request, you don't have to trust any single one particularly. So even if this one is hacked, you are fine as the client, as the browser, which wants to visit this website. So we're going to go through a demo. So I'll just go very quickly through this slide, and I'll keep the last one for the end. One article that you may want to read to get familiar with the central ID of dappy is this one. It's soon 2 years old. Dapps are not decentralized. And okay, so I'll switch to the demo. So for this demo, of course, I'll use dappy browser. And what I have built is a dappy network simulator. So this is just like a dappy network, but I can turn any node down or hack any node, and we will see how the dappy browser reacts to those changes. So first of all, I'm going to check my settings and put them to number of nodes 1 and accuracy 100%. And if dappy browser is in this configuration, it will just act like every DNS browser by asking, by querying a single endpoint when we want to resolve a name. So in my case, okay, let's remove this. Do we have? Okay, so I only have one node, so this is perfect. And I'm going to type anything, and it resolves to a good website. So this is normal because this node is the Canada node, and right now it's good, it's not hacked. So now I'm going to turn it into a bad like mood. So it's undergoing a hack. And let's try to resolve again. And we get on the hacked website. So this is a basic phishing attack through which hackers can steal you private information, etc. So now the second step is to raise this requirement, this synchrony constraint to 2 and 100. And this means that dappy, anytime you visit a website, dappy browser will require 2 valid responses and will require them to represent 100% of the total. So right now, we can't do that, of course, because we only have one node in our dappy network. So let's add a second one. Okay. And okay. So now we have a dappy network with 2 nodes, and one is bad, one is good. The hack is still going on in Canada. So let's try to refresh. And we still can't resolve, of course, because we only have a 50% of the network that is that is in shape. So the message is explicit, and I'm going to turn it back to a good state. And now we can resolve again. And okay, let's go to the 3. Just to illustrate the last point, I need to add a node again. Okay. 1032, add node, save. Okay, so now we are hitting those 3 independent companies when we want to resolve. Let's check the settings. So we can have these settings 100%. So of course it resolves. Of course, if one is bad, it can't resolve, but this is exactly what we want. Because let's say you are visiting a website where you want to transfer $2 million. This inconsistency is not at all. It's too important to ignore. So you don't want to be able to visit the website if you have 1/3 of the network that is telling you A and the rest is telling you B. So the last thing I wanted to show is the tolerance for hacking, because in this example, we have no tolerance, we can't resolve, but you can also lower your settings. And this way, you can tolerate one or more dappy network member going through a downtime or being hacked. So now let's try again to resolve. Okay, so this is wrong because dappy browser is expecting 3 answers that are identical. So we have to lower this to 2, and they must represent at least 66% of the total. So now let's try to resolve again, and we can resolve. And now I can just spam the request, and it resolves every time because there is just 1/3 of the network that is hacked. And this is the demonstration that shows you how dappy changes everything from the DNS that is trustful to the dappy name system that is trustless. So the kind of trust relation that you have when you distribute your website over dappy instead of the DNS is summarized by this schema. When you visit a dappy website, if you are able to browse this website, it means that a great number of corporations have collectively certified to you that the name you are visiting corresponds to a given IP address with a given SSL certificate, etc. So yeah, that's the end of the dappy demo, and that's all. You can join the Discord if you want to ask questions, and that's it for today.
Wow, thank you. That was really as always. You give such clear demos. I really appreciated that. Is it possible for you in the demo? Are you able to make it not be Canada, but maybe France? That's the bad node, and and
Yeah, of course, of course. It's
Yeah.
a random pick.
Okay, cool. I just wanted to check. That was fun. Thank you. Very good presentation. Any questions for Raphael?
I recall a famous movie that had a song that went "Blame Canada."
Oh yeah, I'm sorry, Daryl. I was focused on my demo, but yet next time it will be France or China.
It's okay.
Very good.
We don't mind.
Awesome. I wanted to, again, thank you very much for the demo. Because I have so much to do, I'm going to move along then. Theo, was there going to be a final POC demo today, or is that not scheduled?
No, it's not scheduled yet.
Okay, all right, sounds good. Then in that case, I'm going to move over to the AGM. So as announced at the AGM, we have some new board members. So Schutze was elected to the board. Eric Dimworm was elected to the board. Daryl was elected to the board, and Theo was elected to the board. And I think Theo has graciously offered to give a little statement. So Theo, are you ready?
Yes.
Over to you.
So hi, I'm Theo. You might know me as Theo XD on Discord. So I should probably tell something about me. So I live in Sweden and I study game development, which I hope will come in handy while working with RChain. I was among the first external node validators back in 2020. And that's how I got involved with RChain. And now I'm helping to build a proof of concept of NFT marketplace powered by RChain in our publishing. So I'm glad I got a chance to join the board and actually make a difference. So I hope to do good. And if you want to reach out, easiest is through Discord. Yeah, that's pretty much it from me.
Thank you very much. Any questions for Theo? All right. Thank you so much, Theo. Moving on, Daryl, are you ready for the weekend review?
Yes, I am.
Okay.
And I just want to say congratulations, Theo. I don't think I've had a chance to say that to you yet. So congratulations.
Yes, Steve already said that like 3 times. Steve Handley.
Congratulations, Theo.
Number 4.
Thanks.
Okay, so here is the weekend review for October 21st to October 27th. In the governance committee call, we discussed the unusual process of bringing in nominees after the posted deadline and how to improve the process for next year. We also discussed technical details around implementing our vote for this year. In the work study, Jim did a Rolang tutorial review. On Friday, in the Climate Coordination RCast, we discussed the royal family advocating for the climate in public remarks, Lake Tahoe's severe drought, and a report that says over 80% of people have experienced climate change somewhere in the world. And I also discussed a bit about Dubai and my new electric car that I had to purchase this week because my old Prius broke down. So I'm a new proud owner of the Hyundai Kona Electric and loving it so far. Oh, and I want to say something else. I just read a headline. I guess Elon Musk is now the richest man in the world, at least on paper. And his net worth is worth more than the entire corporation of Exxon, which is kind of an interesting factoid.
Yes, indeed.
On Saturday in the RGov call, there was a Rolang chat live coding. On Monday's Casper Standup, this week's Casper Standup covered RChain's performance data. Essentially, RChain gets 1,000 transactions per CPU per node. So 20 nodes with 20 processors in each gets 20,000 transfers, TPS, transfers transactions per second, and 30 nodes with 30 processors in each gets 30,000 TPS, etc., under reasonable assumptions about the network. So I think Greg was saying that it's possible for RChain to get millions of transactions per second as the network grows. Also on Monday in the RDev member co-op planning, they discussed getting more member participation. On Tuesday in the RChain education, more Rolang live coding. Also yesterday in the communications working group, we had a discussion around the potential investment opportunities from Dubai, working at uniting the Eastern and Western RChain communities and starting a Wikipedia entry for Greg and RChain. Then this morning in the active member hangout, Jim and I discussed Douglas Rushkoff's latest article regarding local communities and what actually defines local in the 21st century. Then Raphael joined and shared his dappy demo around security and explained more details about dappy to me. And that brings us to now.
Very good. Thank you. Any questions for Daryl?
Just want to correct the review of the Rolang tutorial was done by Rich and Kirill. I participated, but it wasn't me doing the review.
Cool. Thanks for that, Jim.
Yeah, so I wanted to weigh in a little bit on the performance results. So again, we still have a lot of work to do, and some of the work that we want to do is not have RChain reporting its own performance data. So we want to identify some independent third parties who will conduct, independent tests of the performance data. And we'll begin reaching out and negotiating those relationships after block merge has been released. So it's going to be fairly time consuming, but what we want to do is to work with some academic institutions. Maybe it could be a master's project or even a PhD project to take it on to do rigorous testing of the RChain performance post the block merge features. So that's just some of the work that we have to do. As Raul said, as we refactor the code, we're finding more and more opportunities to make it both more robust and more performant. And that's ongoing work. It's very exciting to see the dev team so enthusiastic about making it robust and performant. And at the same time, we have to make sure we get releases out the door before we make perfect code. But the main point I want to make is that we don't want to be the final arbiter on what RChain gets in terms of performance data. We want the community to be able to make that determination themselves. That's why the code is open source, and we're just reporting our preliminary results in this regard because the community has been asking. So eventually, we want to have a published, peer-reviewed report on the RChain performance, and we're not at the point where we can release it into the wild and say, okay, arbitrary researchers out there, go ahead and have a go. Well, instead, we want to make sure that the researchers who do have a go at it, they come from well-respected institutions, and they are genuinely independent, and then the community can review the data at that point. Any questions about that? Very good. We have lots of interesting and exciting developments in terms of our prospects. And so I would encourage folks to come to the Friday closed door session if you are interested in that. The board has crafted some interesting positions, and we're in the midst of doing all manner of due diligence on lots of different opportunities. So I think that's about all I've got to chat about. Is there anything else we need to cover? Okay. Well, thank you all for coming, and please stay safe, stay warm, and see you on the other side.